Hampton Roads, Virginia, a small offshoot of Chesapeake Bay at the confluence of the James, Elizabeth, and Nansemond rivers. Once the lifeline of colonial trade, these historic waterways now serve one of the busiest natural seaport complexes in the world. Mammoth nuclear carriers are built at Newport News, while across the bay at Norfolk is the world's largest Navy base. As with many industrial population centers in America, the Hampton Roads area highway system became overstressed. Bottlenecks developed at the once adequate Interstate 64 Hampton Roads Tunnel Bridge on the east, as well as the overburdened James River Bridge to the west. A new transportation link was essential. For nearly a decade, members of the Virginia Department of Transportation analyzed drawing board alternatives of how best to bridge the gap between the north and south sides of the bay without compromising the integrity of the essential James River shipping channel. Their decision, a mile-long, 4-lane, twin-tube sunken tunnel connecting twin trestles from the south to a man-made spit of land on the north shore. Construction of the 4-mile twin 2-lane trestle would be relatively routine. But construction of the sunken tube tunnel would be a different story entirely. In simplified terms, the Hampton Roads immersed tunnel contractors would be required to fabricate 15 twin tubular steel segments, 40 feet high, 80 feet wide, and 300 feet long. In each, create a concrete trough to act as a drain and air duct, prepare a roadbed, line the tube with concrete, seal the ends, add external concrete, tow the tubes for 3 days from the steel yard to a pier near the new tunnel's location, add more external concrete to gain negative buoyancy, and tow into position suspended beneath a gargantuan catamaran. Then, fighting time, tides, and weather, sink 1 segment per month within 18 inches of a previously laid segment on a 4% grade prepared bed at the bottom of a 90-foot wide trench dredged to a maximum of 120 feet deep at the center of the 55-foot deep shipping channel. Join the segments together, remove the bulkheads, join the roadbeds, air ducts, and drains, build a concrete walkway, complete all concrete work, and top it all off with the placement of 2 million tiles. The project demanded uncompromisingly precise marine engineering, combined with highly proficient construction project management capabilities. It took the combined skills of 2 major construction corporations to meet this exacting criteria. The Virginia Department of Transportation awarded this largest single contract in the history of the Commonwealth to the joint venture partnership of Morrison Knudsen Corporation of Boise, Idaho, and Interbeton Incorporated of the Netherlands. The fabrication of the tunnel segments took place at Bethlehem Steel Corporation's Sparrow Point Yard in Baltimore, Maryland. 3/8-inch thick steel sheets were welded together to make 42 by 62-foot panels. These were carried by a series of rollers to a crane that hoisted each panel and draped it over a half cylinder. Prefabricated diaphragms were slipped over the plates and welded into position to create a 42-foot-long ribbed semicircle. 4 halves were then welded together to form a double-barrel module. Interior work started with the installation of J-hooks, rebar, electrical, and mechanical piping. 7 modules were placed into the dry dock and welded together to make 1 tunnel segment. The dry dock accommodated up to 6 tunnel segments. Internally, a concrete trough was laid to act as a drain and air duct. A roadbed was emplaced. Concrete linings of sidewalls and archway were cast in place. Concrete was poured into the surrounding envelope. To air seal each tunnel segment, massive steel bulkheads with mechanical couplers and O-ring gaskets were attached to each end. At this point, 300 personnel had labored approximately 9 weeks, placed over 2.3 million pounds of steel, and poured 7,500 cubic yards of concrete for each segment. The dry dock was flooded and filled within 12 hours. The airtight segments were then floated to an adjacent pier for the installation of 3,500 additional cubic yards of concrete in the exterior envelope. When the draft reached 35 feet, the tunnel segment was ready for the 3-day tow from Baltimore to the Newport News, Virginia pier. At Newport News, another 3,000 cubic yards of concrete were added to the outer envelope. A giant catamaran lay barge straddled the tunnel segment. More concrete was installed until the segment's draft reached 41 feet with a 3% negative buoyancy. Supported by the lay barge, the segment was ready for placement. Concurrent with the tunnel segment fabrication, other awesome preparations were taking place. A mile-long, 90-foot-wide trench had been previously dredged to a maximum depth of 120 feet at the center of the 55-foot deep shipping channel. A rock foundation bed was prepared by a barge-mounted crane equipped with a clamshell bucket. A screed barge was used as an ocean-bottom road grader to emplace and smooth a bed of finer rock particles to seemingly impossible tolerances. 1 1/2 inches variation on a 4% grade in the length of a football field. As this required extreme horizontal stability, a special double-deck barge was designed with separate hulls to form an air gap that was not sensitive to wave forces. Water surface was maintained in this air gap by lowering 4 75-ton blocks and pulling the barge into position with winches. The screed barge itself was maintained at a fixed elevation by a rotating laser system and by the adjustment of lines attached to the 75-ton blocks. Controlled from the surface, the deep water blade meticulously graded the foundation bed. Measurements were taken after each pass, and if necessary, more material was added from the adjacent crane barge and then regraded. With the screeded foundation complete, the tunnel segment supported by the lay barge was towed into position. Time was of the essence. Only 15 hours closing of the shipping channel was allowed, a figure never exceeded, with the average time of emplacement actually taking under 6 hours. To counter the force of winds, waves, and tides, the lay barge was held stationary by 10 2-inch anchor lines. Longitudinal and transverse control lines were also necessary for directing the final joining of segments. 6 complex steps were involved. 1, guided by laser and sighting measurements, the elements were moved to a position just forward of the previously placed section. 2, the elements were lowered onto the bottom and positioned 18 inches from the end of the previously placed tunnel element. 3, railroad-like couplers were attached and the connection checked by divers. 4, the segment was pulled forward by hydraulic jacks, bringing the gasketed surfaces into contact. 5, from inside the tunnel, water was pumped out of the space between the dam plates, allowing tremendous external hydrostatic pressure to butt the suspended segment securely against the previously placed section. And 6, inside, a steel liner was welded at the joint and the connection was grouted. Once emplaced and sealed, each section was covered with rock to add ballast as well as to provide a protective covering. Cement trucks and other large construction equipment were sealed in and lowered within the first sections. They would be used for nearly 2 years before open-end access would be available. Inside the tunnel, bulkheads were removed. Concrete linings were installed at the joints. Concrete walkways were emplaced on the sides. More than 2 million tiles laid on the walls, and ceiling panels emplaced. Exhaust ventilation ductwork lies within the false ceiling, while fresh air is routed under the road surface. The final length 300-foot tunnel segment was emplaced with only 7 inches clearance on each end, and on July 19, 1989, in a shower of sparks, a symbolic door was opened to the future. Proud transportation officials congratulated Morrison Knudsen and Interbeton construction team members for proficiently executing a formidable engineering feat. With the completion of the new Hampton Roads I-664 Tunnel Bridge project, the 45-minute driving time from Newport News to Suffolk will have been cut in half. Since officials estimate that as many as 80,000 cars will use the tunnel daily by 1991, their stated purposes will have been accomplished. First, the relief of heavy traffic congestion through the I-64 Tunnel Bridge to the east and over the James River Bridge to the west. Second, the inspiration toward economic development in new as well as existing communities on both sides of the bay. For the members of the Virginia Department of Transportation, the decision to award this extraordinary project to the Morrison Knudsen-led Joint Venture Association with Interbeton has proven to be a wise one. The Hampton Roads I-664 Tunnel Bridge project is a magnificent example of mankind's ability to cooperate with nature and with each other to reshape the face of the earth for the benefit of mankind. When there is a difficult job on the line, anywhere on the face of the earth, wise men call on the people who continue to prove they will get the job done. Morrison Knudsen Incorporated of Boise, Idaho. Interbeton Incorporated of the Netherlands.